All right, you guys, welcome back. We are continuing on with exponential functions. All right, now this one, okay, you notice there are no formulas for us, okay? And so we have to utilize, okay, a predetermined formula that's out there for exponential functions to help us solve this problem. All right, it says a town has a population of 10,000 and grows at 5% every year. What will the population after t years to the nearest whole number? Okay. So what we're going to be using is what is an exponential growth or decay model. Okay, and there was a key word in there, and you probably already know what it was. Okay, was that it said that it grows. Okay, all right, so the basic form of this formula is y equals a parentheses 1 plus or minus r to the t. Okay, and like I said in my previous video a couple days ago, was that you can Google that formula and it'll be presented to you with lots of different letters, but it's the same idea. Okay, y, okay, that's your final amount. So final. A is your initial. R is your rate. T is your time. Okay, then you have this plus or minus. You use plus for any time you see a word that represents growth. So like the word grow, increasing. All right, you use minus anytime you get an indication of decay. All right, so lots of different words, decreasing, depreciation in car values. When car values go down, there's a decline. Just any words that represent one of those two ideas, that will determine which equation I use. So since my population is growing, y equals a times 1 plus r to the t. All right, I have an initial population of 10,000, and I'm growing at a 5% rate. So 5%, so that's going to be 1 plus 0.05. Okay, and what will the final amount be after 5 years? Okay, so if I go over to Desmos, 10,000 parentheses 1 plus 0.05 exponent 5. So my final amount is 12,762.82. And let's see what we're rounding. We're rounding the nearest whole number. So that is 12,763. So 12,763, submit. There you go. Okay. All right. Now, he started off with a very basic exponential function and then converted b into a growth of 1 plus r or 1 minus r. So like I said, there are multiple ways this formula can be presented. All right. One more, and then I will leave you to it in this video. All right, an element with a mass of 670 grams decays by 27.3% per minute. How much of the gram is remaining after 9 minutes, round to the nearest tenth of a gram? All right, so y equals, we have an initial amount of 670 times 1 minus, I'm going to use minus because I have a decay of 27.3%, so 0.273, okay? And how much is remaining after 9 minutes? All right, so now I just switch over here to Desmos to type that in or use your calculator. Oops, let's delete that. 670 parentheses 1 minus 0.273, and then my exponent of 9. All right, so 38.008. Okay, so the nearest tenth, okay, that is 1 decimal point. So I will type that in. So 38.0, because that is to the nearest tenth. Okay, submit my answer, and there we go. Okay, now I understand he did write 38, but if we're being accurate, the nearest tenth of a gram means you do have 1 decimal point, even if it's a 0 behind the decimal. Okay. All right, so that is how you're going to complete this set of problems in your Delta Math assignment. Okay, good luck.